All right. Let me share the screen. Okay, does anyone have any questions when it comes to the next chapter? I know it's somewhat new, the information, so I was expecting a lot more questions than I received. So the area of, we've talked about in depth the area of a parallelogram, the area of a triangle, the area of kites and rhombuses and stuff like that, and we know how to do the formulas. So do I have any questions when it comes to perimeter and area of any of the quadrilaterals? So this chapter is like, the reason we keep it at the back end of geometry is because this chapter is very uninspiring in the sense that it's just a bunch of formulas. You either know the formula of a trapezoid or the area of a trapezoid and you know how to use it, or you can go look it up. Same thing with area formulas for all of the other quadrilaterals that we refer to. So there's not a lot of mathematics, if you will, or conceptualization. It's like, do you know the formula? Do you know how to use it? If not, go look it up. So there's not a lot of stuff that we can do with it. So I really don't have a lot to input other than just telling you what the formulas are. There's not a lot of theorems and stuff like that associated with this chapter. But what I do want to talk about in passing is the density section. And I don't know if any of you have had chemistry or will be taking chemistry in the future, but when you take chemistry in the future, okay, so before I start off with this tangent, let me talk about what is the value of mathematics when it comes to science. So in education, we have a term called STEM, okay, STEM, and STEM stands for science, technology, engineering, and math. So the question is, why is math lumped with science? Well, because up to now, I think you guys have had like physical sciences, life science, environmental science, and stuff like that. Those sciences, not to diminish the value of those sciences, but those sciences are like a brief survey of the three more in-depth sciences. And it's basically a bunch of facts that you are asked to memorize in those classes and then regurgitate on a test. But your core sciences are your biologies, chemistries, and physics. And when you take those classes, there's a lot more math involved. Math and science and these three sciences go hand in hand. Math has helped influence how that science is done, and science in turn has influenced how the math has developed. Like a good story is Newton, who was the most famous physicist of his day, was asked why planets orbited in elliptical patterns. And he didn't have an answer for that, okay? So over the summer, he goes and goes and studies why the planets orbit in ellipses and not circles. So at the end of the summer, he comes back and he says, okay, here is the mathematical reasoning as to why planets orbit in elliptical patterns and not circular patterns. Oh, and by the way, in order for you to understand all this stuff that I found and the math that I've done, you have to understand this new math that I created called calculus. So this scientist, not only discovered why planets move in ellipses over the summer, but also created a whole new classification of math called calculus also over that summer. People spend 18 months trying to learn calculus. He created it in 3. So kind of uninspiring, if you will. Makes me feel uninspired because this man created all of calculus in a summer, and all I did over the summer, last summer, was clean out my garage. So, oh well. Yeah. So long story short is math and science go hand in hand, okay? So when you take your chemistries and physics and biologies, and more so for the chemistry and physics, there's a lot of math involved. And one of the problem types that you'll get in chemistry is what we call unit conversions. Unit conversions, where you convert something from one set of units to another. So as you know, when it comes to everything that we measure, we usually have two types of ways we measured it. So an example would be like if we measure distance, we can measure it in inches, feet, yards, miles, etc., or we can measure it in meters, kilometers, etc. Okay. Same thing with the mass. We can measure it in grams, kilograms, etc., or we can measure it in ounces and pounds and stuff like that. Temperature, we can measure it either using Fahrenheit or we can use Celsius. And you would like, because like, for example, in the United States, we use a lot of the English system. So we do a lot of measurements of temperature, for example, using Fahrenheit. But if you go across the water into Europe, they measure temperature in Celsius. So the question is, how do you go from Fahrenheit to Celsius and back and forth? So to do this, we do these things called unit conversions. And I'm going to show you how we do that. And it's actually just working with a lot of fractions, right? So let me give you an easy one. Let's say, for example, I am moving at, say, 40 feet per second. Okay. And I want to know, well, if I'm moving 40 feet per second, that's all nice and well, but how do I know how fast I'm moving in miles per hour? Okay. So I got a speed, 40 feet per second. How do I convert this into miles per hour? And the way you do this is say, okay, well, it's 40 feet per, which is, per means division, second, per 1 second, okay? And then the way we do this is say, okay, well, if it's 40 feet per second, well, how many feet are in a mile? Well, we know that there's 5,280 feet in a mile. So the first thing we want to convert is from 40 feet per second to 40 feet per mile. And the way we do this is we say, okay, 1 mile is the same as 5,280 feet. Okay. And this fraction is known as a scale factor. So we say 1 mile over 5,280 feet, because that's what 1 mile equals. And if you do the math, you can see what happens. You have feet in the numerator and feet in the denominator. And what happens is these units cancel. And so when you multiply across, what you get is miles in the numerator over seconds in the diameter and the denominator. And you just multiply across 40 over 5,280. And you can plug this into your calculator and get some decimal value. And that will tell you how many miles per second that you're moving. But we're not done. We're not interested in miles per second. We want miles per hour. So miles in the numerator per hour. So hour in the denominator. Well, how do we go from seconds to hours? Well, we know that we may not know how many seconds are in an hour, but we know that 60 seconds is in 1 minute, right? So we can say, okay, well, I got 60 seconds per 1 minute. And we do the same thing. You know, the miles again cancel, the seconds cancel out, and that leaves me when I multiply across the units become miles per minute. And when we multiply across, we get 40 times 60 is 2,400 over 5,280. Okay. And again, you can plug this into a calculator and get some decimal value. And that's all nice and well, but again, that gives me miles per minute. I'm not interested in miles per minute. I want miles per hour. Well, we know that 60 minutes is equal to 1 hour. So we can use the last scale factor and say, okay, well, 60 minutes is 1 hour. And we do the math, we say, okay, 60 times 2,400 is 144,000 over 5,280. And if we see what happens to the units, the mile, I mean, not the mile, sorry, the minute in the numerator and in the denominator, they cancel. And that gives me miles per hour. And if I do the math in the calculator, because God knows I can't do this in my head, because you know I'm not that good at math, we get 144,000 divided by 5,280, and we get approximately 27.3 miles per hour. Okay. So that means that 40 feet per second is the same as going at 27.3 miles per hour. And this is what we call unit conversions. We basically use scale factors and manipulate those scale factors so that we can arrive at the units that we're looking for. Right? So let's do another one. Okay. So let's say, for example, I got a liquid, okay? And I put some salt in it, and I got, say, it's a solution that has 100 grams per milliliter. Okay. And I want to know, well, if I got 100 grams per milliliter, how many grams per liter is that? Okay. How many grams per liter? So we have grams per milliliter, and I want to convert it to grams per liter. So if you look at that, you say, okay, well, I'm going from milliliters to liters, so I need to know the relationship between milliliters and liters. And I would say, okay, 1,000 milliliters equals 1 liter. Now, remember, we want grams per liter, so we want the liter in the denominator. Okay, we want the liter in the denominator. So how do I get rid of the milliliters? Well, I have to multiply. So use the scale factor so that the milliliters cancel and I have liters in the denominator. So I say, okay, well, 1,000 milliliters over 1 liter. Okay. And the reason I put milliliters in the numerator is because I start off with milliliters in the denominator and I want to get rid of it, so I have to multiply it with something in the numerator so that the milliliters cancel out. And if we do the math, we get 100 times 1,000, which gives me 100,000 grams per liter. Okay. So when you use scale factors, you have to know what type of end unit you want, and you need to see what units need to cancel. And based on what units need to cancel and where they are initially, that will tell you how to set up your scale factor. So let me give you guys another example. And I want you guys, everyone, to do this. Say, for example, I have something that's decaying at a rate of 150 grams per second, okay? And I want to know how many, if it's decaying at 150 grams per second, that means this is how much mass I'm losing per second. I want to know how many kilograms per hour am I losing, okay? How many kilograms per hour? So try to sort of struggle through this and see if you can get a number. So I'm losing something at 150 grams per second, and I want to know how many kilograms per hour am I losing. Okay, does anyone have an answer or a way of we're going to do this? So, Mr. Montford, can you give me a suggestion on how we're going to start?
You multiply. Oh, wait, no. 150. That's 150 equals h over 5, right?
H over 5, what do you mean?
Wait,
150? It's
yeah,
150.
150.
It's grams per second. Yeah.
Okay. Okay.
So I want to convert this into kilograms per hour.
So you would divide 150 and 5.
Why 5?
And, oh, that's an S on the bottom, ain't it?
Mm-hmm.
Okay. Mm,
So what is my end? I want to get to kilograms per hour. So I'll need to convert grams to kilograms. What is how many grams are in a kilogram?
grams in kilogram.
So I'll give you the clue. 1,000 grams is equal to a kilogram. So the question is, do I do 1 kilogram over 1,000 grams, or do I do 1,000 grams over 1 kilogram? Which one of these do I use? The left or the right?
Right.
The right. Okay, so let's see what happens when I use the right. So 1,000 grams over 1 kilograms. So let's see what cancels. So we have grams in the numerator, so nothing happens. And we got seconds and kilograms in the denominator. So if we actually do the math, we get grams times grams over seconds times kilograms. Is that helping us achieve what we're looking for?
No.
No, no. We want to get rid of grams and replace it with kilograms. So instead of using 1,000 grams over 1 kilogram, what are we going to use?
1 gram over 1,000 grams or kilograms.
Yeah, 1 kilogram over 1,000 grams. Okay. Now, let's see what happens. If we multiply across, we have both grams in the numerator and denominator. So since both units are in both the numerator and denominator, the grams unit cancels. So when I multiply across, what I'm going to end up with is kilograms per second. Okay. So that's 150 kilograms over 1,000 seconds. Now, are we done? No, we're looking for kilograms per hour. So we got kilograms per second. So now we want to find a way of getting rid of the seconds in the denominator and replacing it with an hour. So I'll give you a conversion. 3,600 seconds are in 1 hour. So what would be my scale factor?
It would be 3,600 seconds over 1 hour.
Yeah, 3,600 seconds over 1 hour. So question, Ms. Sizemore, why did you write the scale factor this way and not 1 hour over 3,600 seconds?
Because the seconds have to cancel each other out.
Correct, correct. So if you do the math with just the units, since you have seconds in both the numerator and denominator, they cancel. And when you multiply across, what the result is going to be kilograms per hour. Now, again, not an expert in math, so can't do this in my head. So you're going to have to do it in a calculator. So 150 times 3,600 divided by 1,000. So that means you're losing 540 kilograms of product per hour. Okay. And actually, this is how radioactive decay works. Like radioactive decay is something that loses mass over a given time. And this is how we actually convert these things. Okay. Now, let's talk about another use of unit conversions. So say, for example, I'm traveling at a speed. So another name for a speed is velocity. So say I'm traveling at a velocity of, say, 60 miles per hour. Okay. And I'm driving at this speed for, I'm driving at this speed for, say, 3 hours, okay? Or let's say 3.5 hours. I want to know how many miles did I drive. Or let's do another one. Say I'm driving at a speed of 60 miles per hour and I get to Atlanta in an hour and a half. How many miles did I drive? Okay. So my speed is 60 miles per hour. Now, so I want to know my question is how many miles did I drive? And I drove for 1.5 hours. Okay. So if I multiply this by 1.5 hours, well, what happens? Well, the hour is in the denominator here and it's in the numerator here because it's just how many hours I drove. So that if I do the math, then the only thing I'm left with is the miles that I traveled. And if I do the math, 60 times 1.5 is 90 miles. Okay. So if you know a rate of something, okay, of any kind of rate, or if you know the density, and we're going to talk about density in a minute, you can figure out a lot of things, okay? So let's do another one. Let's say, for example, I'm traveling at 80 miles per hour. And I want to, hold on one second, guys. Sorry. So say, for example, I'm traveling at a speed of 80 miles per hour and I want to cover a distance of, say, 175 miles. Okay, so I look at I put it into say Google Maps or something, and I see that the average speed on the interstate is 80 miles per hour. I know it's 70, but most of us drive 80. And the distance between where you are and where you want to go is 170 miles. Well, how do you calculate how many hours you're going to be driving? Okay, well, you say, okay, well, I know I'm driving at 80 miles per hour, and I know the distance I want to cover is 170 miles. But the problem is, so what I'm looking for, my answers has to be in hours, okay? So if I just multiply like this, nothing cancels. I get miles times miles over hour, okay? Does everyone see that? Nothing here cancels. Because if I'm multiplying 170 miles, it's the same thing as multiplying it by 170 miles over 1. Okay? So nothing cancels. Now I need the hours, but the problem is this is a fraction. It's 80 miles per 1 hour. Okay. So some of you may say, okay, well, why don't I do this? 1 over 170 miles. Okay. Well, there's a problem with that, because if I do the unit math and see what I end up with, I don't end up with hour, I end up with 1 over hour. And that's not my answer. That's not what I'm looking for. Okay. So instead of multiplying by 1 over 170, what I would do is say, okay, I'm traveling at I need to travel 170 miles, okay? And my rate is 80 miles per hour. So I want to cancel the miles and replace it with hours. So I say, okay, well, this means I can go 1 hour over 80 miles. Okay. Now, if I do it this way, now notice the miles cancel and I just am left with an hour in the numerator. And if I do the math, I get 17 over 8 hours, which approximately is 2.125 hours. Okay. 2 1/8 hours. So that means that if I'm going to be traveling at a speed of 180 at a speed of 80 miles per hour, and I got to go down a road of 170 miles, that it's going to take me 2 and a little bit less than a quarter mile, 2 and a little bit less than a quarter hour to cover it. And so this is the other use of these conversion ratios. So if you know the rate of something and you want to find one of the quantities, you can use that if you're given the other quantity. So let's see how we use this with recipes, okay? So let's say, for example, we're baking something and the recipe says that you have to add, say, 4 cups of flour for every 3 eggs. Okay, 4 cups of flour for every 3 eggs. Right? Now, you want to know, you're making more. So you're going to have, say, 7 cups of flour. Okay, you're going to be making a cake with 7 cups of flour. How many eggs are you going to use? So we're going to do this the same way. Okay, now there's many options that we can do. We can multiply by, if we multiply directly, 4 cups over to every 3 eggs times, well, 4 cups per 3 eggs times 7 cups of flour, then we still, the units don't cancel. So our result, we're looking for just eggs as a result. The units don't cancel. Because if we do the units math, we get cups times cups over the number of eggs. And that doesn't help us. That's just nonsensical units. So remember, we have this rate, 7 cups per 3 eggs, and we have 7 cups of flour that we're going to use. So we want to find the number of eggs. So we want to end up with just eggs at the end of this equation. So instead of multiplying directly just by 7 cups or saying, okay, 4 cups per 3 eggs times 1 over 7 cups, that's still not going to give us what we're looking for, because you'll get 1 over eggs that way. So we can say, okay, so if I'm looking for eggs, if it's 4 cups per 3 eggs, another way to say this is 3 eggs per 4 cups. So the ratio is still the same. It's 4 cups per 3 eggs, or 3 eggs per 4 cups, times 7 cups of flour. And if we do the math, the cups cancel and that leaves me with just eggs. So if I multiply across, I get 21/4, which is 5 1/4 eggs. Okay. So unit conversions can be a little bit tricky, but you need to pay attention to what you're trying to achieve. What is your end goal? And once you know what your end goal is, that will help you determine what scale factors you're going to use, and also which way you're going to write these ratios for scale factors. You want it so that the units cancel in such a way that you end up with the units that you're looking for. Any questions? So let's say, for example, you are doing a recipe and it asks for 7 tablespoons of milk for every 5 cups of flour, okay? 7 tablespoons for every 5 cups of flour. Now you want to know, now you have 11 cups of flour. You want to know how many tablespoons of milk. Determine this, please.
Would it be 15.4 tablespoons?
How'd you get it?
I put 7 tablespoons over 5 cups and multiplied it by 11 cups and got 77 over 5, and that simplified to 15.4.
Okay, so 7 tablespoons over 5 cups, and you multiplied it by the number of cups, and you got 77 over 5, because the cups cancel, tablespoons, which you said was what, 15.4?
0.4.
Okay, good, perfect. All right. So practice with unit conversions. I know it is a little bit confusing, and some of you are going to find a little bit of a challenge trying to figure out how to set up your scale factors. But the more you work with it, the better off you'll be. And it's kind of, to be honest with you, I'm kind of disappointed that like Google does all this stuff for you in the background, because that's exactly what it does. Like when you type something in Google Maps, right, and you ask for directions to a certain store, it says, okay, well, this is the number of miles the store is away from where you are, and the average speed on that road is, say, 40 miles per hour. So it does the math for you. And so it tells you, that's how it tells you, oh, if you leave now, you'll reach here at, say, 5 p.m., because it calculates the number of how much time it takes. And this is what it does in the background for you. But the problem is when they do this in the background for you, you stop having the ability to be able to do it yourself. But unit conversions are really important. It is involved in all facets of science and math, and even home ec when you're trying to cook. And anything you do in life, there's going to have to be conversions that you have to do where you're converting from one thing to another. And this is a key skill that you need to learn. So please practice with it. And if you need extra problem types like this, I can definitely give you some. Now, I want to talk about one type of concept: mass versus density. Okay. And you're going to need unit conversions to do these types of problems. And we're going to elaborate more tomorrow about mass versus density, but I just want to leave you with the definition. Mass is the amount of stuff in an object. Okay, amount of stuff in an object. The amount of material in an object. And we measure mass in 2 ways. We can either use like grams, kilograms, or we can use the English conversion of that, which is in pounds and ounces and stuff like that, tons, etc. So when you step on a scale, right, it's measuring your mass. So when you look at it and you weigh 165 pounds or 125 pounds, the thing is this: the scale is like a computer or of sorts. Because when you step on a scale, you're not measuring directly your mass, because what you're measuring is not only your mass, but the force of the Earth's gravity pulling down on top of you. So the scale takes into account the speed of gravity, which is constant, and it divides it out. So what you get as a readout from the scale is strictly your mass. Okay. So mass is the amount of stuff in an object. Now, say for example, you put say you take 5 grams of flour and you put it in a pitcher with 2 liters of fluid. The ratio of mass to fluid is known as density. So the density is how thick or thin or how much mass is in a given volume. So the way we measure density is like grams per liter, or another common way is pounds per gallon, etc. Okay, grams per milliliter, etc. And when you have density, density helps you determine a lot of things. Things that are more dense, that means there's more mass per given volume, is always going to sink to the bottom. Okay, so things that are less dense will always float on top of things that are more dense. So I'll give you an example. Ice always floats on top of liquid water. Well, why? Because when all ice is frozen water. So when water freezes, it actually becomes more dense. It has more volume, more mass per given volume than the liquid water. So because of that, the ice floats on top because it is actually less dense. Okay, so water has more mass per volume than its solid form. So that's why ice floats. Oil and water, as you know, when you put oil in some water, when you mix it, the oil rises to the top and the water sinks to the bottom, because oil is actually less dense than water. Okay, so there's less mass per unit volume in oil than there is in water. So that's why oil rises to the top. Okay, so that's the key characteristic of density. So if you know an object's mass and you know an object's volume, you can actually calculate the density of an object. Okay. So for example, if you blow up a balloon, if you know the volume of the balloon and you know how much air you breathed into that balloon, you could calculate the density of the balloon. And why helium balloons float up into the sky, whereas the air that you breathe into a balloon doesn't, is because when you blow up a balloon with just helium, it has less volume. It has less mass per volume, less density than the air around it, so it floats. Okay, so that's a brief taste onto the difference between mass and density. So mass is the amount of stuff in an object. Density is the amount of stuff in something over a given volume. And we're going to do problems with this tomorrow. Any questions? All right.
Wait, I got a question on my ingenuity.
Sure.
I just want to be sure. It says, like my final assignment is this Friday. It's the unit test. Is that correct, or is there more?
The unit test for what?
Like volume of pyramid, volume of cylinders, and all
Yeah.
that.
Well, you don't have to wait till Friday. As soon as you get it done, that'll be good.
Okay.
All right.
All right. So that's it
what?
for math then?
Yeah. So once you get done with that unit test and you pass it, you're done with the course.
Okay. And if I get it, like, say, done today, I won't have to come to the Zooms anymore?
No.
Okay.
Yeah.
Thank you.
Any more questions about just this or any other topic or anything about ingenuity?
So is this topic coming up?
Yes.
Okay.
So go ahead.
Oh, I just said that sounds fun.
It is. In fact, it is quite fun. Too bad that we don't have class, because I would have brought in a lot of examples, and we would have calculated like the density of whipped cream and stuff like that. So it's pretty cool. So another thing that just for this class wise, remember that all of the assignments need to be done by next Sunday, so that I don't have to put in zeros for things that you've not done, right? And once you're done, you're done, okay? So once you take the last unit test, you do not have to come to the Zoom meetings anymore. Any questions?
So you want everything done before the 15th, which is next Sunday?
Yes.
All right.
I think next Sunday is the 7th, if memory serves me correctly. It might, I don't know, maybe 8th. I don't know. I can't determine it. So 30th is, let's see, 30th is Thursday, 1st is Friday, 2nd is Saturday, 3rd is Sunday. So it'll be the 10th. So I need everything done by May the 10th. Yeah.
Okay.
All right. Any more questions?
Nope.
All right. Well, if there's no more questions, then I will see you guys tomorrow. Have a nice day, guys.
You too.